Okay. All right. First issue. Okay, there are 3 parts to the test for chapter 6, just like chapter 5. This is the one we went through yesterday, procedural, pretty simple. I mean, it's just knowing what to do. After going through the review, everybody should be fine. There's a little more to this. Now and some of this has been a while since we've done it, so probably a good thing that we're coming back to it. Okay, we got to simplify this, right? We're supposed to, the directions say, to simplify the expression, write in terms of positive exponents. So we can't put negative exponents in our answer. We have to put positive exponents. Okay, so what are we going to do with this?
Lawrence Bonenkamp to the office. Lawrence to the office.
Suggestions? Okay, divide 12 by 4. So we got the numbers to deal with. In fact, we could split this thing up, couldn't we? We could split it up into a ratio of numbers times a ratio of x's, right? We're just going to divide this up or partition it by like bases. Then I've got x to the 9th over x cubed. And then finally, we've got y's. Y squared over y to the 11th. Okay. So, what do we get? 12 over 4 simplifies to what? 3. Okay. X to the 9th over x cubed simplifies to x to the 6th. Piece of cake. Okay, now what about this last one? Y squared over y to the 11th. Okay, good. 1 over y to the 9th, right? Because y to the 11th is more powerful than y squared, we're going to subtract the 2 from the 11 on the bottom, right? So we get...
That's it? That's simplified?
That's it. That's simplified.
That's easy.
Don't say that.
Okay? Right?
Yep.
Good. And then we want to enter that. Well, let's enter it. Just make sure we know what we're doing. Okay, how would I put that into Moodle?
Parentheses.
Okay, I could. Now, here's an issue. Listen, please. I could put parentheses around the top. I don't actually need to this time because I've only got one thing on the bottom, but it's not a bad idea. It would work. It'd be fun. In this one case, though, I don't have to. Now, if I had something like y to the 9th times z on the bottom, then I would have to for sure put parentheses around the bottom. It wouldn't be a bad idea to put them around the top also, right? But here, watch what happens if I just put in 3, whoops, 3, 3 times x to the 6th. I put 3 times x to the 6th. Oh, you could, yeah, you could. Yep. Yep.
You make it way more difficult.
Way more?
Way more? Yes, way more.
Okay, now always hit display response on these, especially on the test, right? You got to make sure that you're putting it. Does that look like what we want? It does. So now we can hit submit. Okay. All right. Aren't we good? Okay. So what about this one? Okay, let me rewrite that a little bigger. Okay, I'm going to ask you one time politely to not be talking here. I know that takes me sometimes to write things down, but don't get off. It wastes too much time. We're always having to work to get back on track here. So just be patient with me between problems, but don't talk. What do I do here if I've got a product of 2 times x to the 4th all taken to the 5th?
Can you distribute the 5 to 4?
Bingo. We're going to distribute the 5 to both parts. So 2 to the 5th is what?
10.
No. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
18 times 5.
Okay, now what about this? I've got x to the 4th to the 5th. 20th. Okay, now why is that? Somebody explain to me, please. Why is that x to the 20th instead of x to the 9th?
It's a separate.
There's 5x.
You're distributing it throughout the whole thing.
Okay, true. But what I'm actually doing is taking x to the 4th to the 5th, right? When I take a power to a power, I multiply the exponents. When I multiply like bases, I add the exponents, right? Okay, so what I mean by that is, here are the rules.
We're just showing an example where you would add.
Yeah.
A to the m to the n would be a to the m times n. A to the m times a to the n would equal a to the m plus n,
Okay.
right?
So just parentheses make a difference.
Yeah, right. Because we're taking a power to a power. Yeah. Okay. Okay. This is a really simple one. All we're doing with this now look what this process is asking us to do. We're adding up polynomials. If we're adding or subtracting polynomials, all you do is combine like terms. That's it, right? So in this case, if that had been a minus sign, I'd have to distribute the -1 all the way through first, right? And then add up like terms. But in this case, because I'm just adding, there's nothing to distribute. X to the 4th, well, how many x to the 4ths are there? I've got, looks like 3 of them. 1x to the 4th plus 2x to the 4th gives me 3x to the 4th. How many x cubes do I have? 1.
Okay, that's
Right? How many x squares? 1. How many x's? 2. And 2.
They're multiplying ones
Yeah.
at once.
Okay? Right. They're harder. They're harder.
I still can't figure them out.
Okay, let's take this one. Okay, so somebody get us started here. How do we multiply 2 polynomials like that? Okay, well, we call it FOIL, but it really means expand or distribute, right? So now, which one should I distribute from? The smaller one with 3 terms, right? So let's do this. Let's distribute the x squared. And if we do that, what do we get? So x squared times 4x cubed is, okay, x squared times x squared. Okay. Okay, now we got to distribute the x. Okay, so what's x times 4x cubed? So let's line it up with that column. Notice that if you're going to do it this way, which I think is good, if you're going to add them up vertically like this, you got to make sure you always leave a column for every power of x, right?
Yeah.
So 4x to the 4th, what's next? X cubed. And finally, if we distribute that -2, now what? Did you say that again? plus 6x. Okay, we just add them up. That's all you do. That's it. So plus 5x to the fourth. What do we get here? Minus 10. Oh, whoops, fifth. You're right. Sorry. You're right. And then the 2's cancel, so I just get minus 3x squared plus 8x minus 4. Done. Make sense?
So the exponents stay the same. You don't
Yes.
add them. Okay.
Yep. When you're adding like terms.
Wait.
Okay.
Negative 3 plus 1 is negative 2. If I just,
This one?
yeah.
So negative 3 plus 1 is negative 2 plus negative 8 is negative 10.
Oh, sweet, okay.
All right. Okay, what about this? Now these are a little bit awkward, I think. Okay, so I probably, I won't do it this year, but that's a project for next year. I'll probably write these so they look better. But you have to rewrite for this year. Sorry, you're stuck with it. So this first one here, if I rewrite that, that looks like y equals x to the 11th
That's all we gotta do?
minus, no, you have to decide. I guess I should read the directions, huh? So the directions want us to select all of the following that are polynomial functions, right? So there, if I rewrite the first one, it looks like that. Now, is that a polynomial? Yeah, it is. Right. What are the two criteria for polynomials? Say it again. Okay, the exponent has to be what kind of number? Whole number. It has to be an integer, a positive integer, or 0, right? Okay, so that's check, right? That works. Okay. What about the coefficients and the constants? What do they have to be? What's their restriction? Say it again. Real numbers. The only thing they can't have are i's. They could be square roots, they could be fractions, they could be negative, they could be positive, but they just can't have an i in them. Yes?
You said that exponents have to be whole numbers. Can you have like x for 11.7?
No, that's not a whole number. No. Can't. It has to be.
Well, I mean, for the polynomial, can you have that?
Oh, you could, but it's not for a polynomial. Yeah. Yeah, you could, sure. Well, a square root, x to the 1/2, x to the 0.5 is the same thing as the square root of x, for example. Okay. We'll see that next chapter. Okay, so this one works. There's an example of that works. Okay, let's check the next one. Okay, this guy looks like minus square root of 111 times x to the 121 minus 65 x to the 23rd plus 45 x squared.
Yeah,
Okay.
that's all good.
Not a real number.
But
What's
you
not a real number?
You missed a number.
Wait,
but it's all-
where'd you get that?
Negative 21.
Actually, no, that's a real number, I guess.
Negative 21.
Oh, minus 21.
Now it's complete. That's right.
Oh, I have.
What do you buy it?
No.
No.
How come?
Negative.
Negative, 1 over squared.
Okay, but
But
it's on the
It is.
outside, so it doesn't.
right. Okay, see the difference. The negative sign can be outside. It's just that if that were inside the radical, if it were a square root of a negative number, then that wouldn't work. Right? But that one's okay. That one's okay. Because that's a number. Square root of 111 is just some number times negative 1 makes it negative. Big deal, right?
It's like 11.7.
Yeah, it's going to be something like that, right? It's going to be a little less than 11.
Yeah, it's like 10.72.
Something like that. Something that ish. And then all these exponents work, right? So that one's okay.
All right, that goes.
Okay, so about 10.5,
5.2 off.
10 point, let me say 10.56. What is it?
5.3.
Oh,
said 5.7.
Okay.
Right, no, I didn't. I said 7.3.
You said 7.
That's
Come on.
I forgot.
Oops, sorry, we'll keep going. Okay, what about this guy?
Okay. 4 minus 3x. Plus?
Okay?
No.
Okay, what's wrong with that one?
Okay,
I don't know.
Is that a no?
I is a real number.
Is pi a real number?
No.
Yeah? Does it have an I in it?
No.
It's a real number
It's
then.
an irrational number.
It's irrational, but it's real.
Okay.
Oh, pff, yeah.
Oh, he got you there.
Okay, so that one's good. This one was good. That one was good. How about the next one?
I don't think so.
No.
No.
We don't have to go any further, do we?
No.
Pi is not an exponent.
Can't do that.
Wait, so do all of your exponents have to be like whole numbers?
Yes.
Oh,
So that one's no good.
I didn't.
Okay, and then last opportunity. Let's try this guy.
I'm going to say yeah.
No.
Again,
No.
I'm going to say yeah. I'm going to say yeah.
Plus x minus 1 divided by x plus 7.
I'm going to say yeah.
Okay, what do you think?
Yep.
Here's some yeses. I'm hearing some nos.
Ow.
Okay, here's the.
Yeah, no.
Would everybody agree this is the potential problem?
Yeah.
Okay, now if I write
It's not over X.
if I write 1 over x as a power of x,
Oh, I didn't see the power.
that would be x to the minus 1, wouldn't it? Can't work. The x's can't be in the
Oh, I see.
denominator either, right? Because if I rewrote that, I could rewrite that as minus x to the minus 1 power. That's negative. No good. Okay. So these two are next. The other ones are okay. Right? Fair enough? All right. Okay, this guy.
I think we should submit that last one.
Submit the last one?
Yeah.
You want to check it? Just make sure, huh? Don't trust me. All right.
I just want to see. Yeah, yeah. Awesome.
10 out of 10. All right.
Wait, you said that last one was right?
No.
Oh, okay. I thought you marked the third one.
You did the
That's in mathematics. 999.
Okay.
Okay, a lot of questions on these.
I don't know.
These are very, very simple, but we haven't done it in a while, so I want to review this. A lot of questions on it.
I don't know that.
Okay, so here's what we know about these now. Well, think what we're asking. We're saying they're giving you a function f of x, and they're saying as x approaches positive infinity. Now, you could just as easily say negative infinity there. This one happens to be positive. They're asking what does the function approach? Does it approach positive infinity? If so, enter 999. Does it enter negative infinity? If so, enter negative 999. Or neither. Okay, now we know it's going to be positive, isn't it? Now we know always with a polynomial, this is what has to happen. We know that as x approaches positive infinity, that just means that we're going way out there,
Yeah.
right? If we go way out there, or if we approach negative infinity and go way out there, we know that the polynomial has to expand infinitely, has to blow up in both directions. The question is just, is it going to blow up positive or negatively, right?
Yeah.
And that's all we have to find. Now, the way we find that is just by looking at the sign of the leading term, the dominant term. As x gets really big, the only term that's going to matter is that first one. The other ones just get insignificant. The dominant term is going to dictate what the polynomial does when x gets really large, positively or negatively.
So if that's a negative, it just goes the other way.
So we have to take into account two parts of that. If we look at that leading term, 2x to the 9th, there's two parts. There's the coefficient and the x to the 9th. All I have to do is just determine what's the sign of the coefficient. It's always positive in this case, right? And what's going to be the sign of x to the 9th when we plug in a value. Well, here I'm plugging in a positive value for x, right? So if I put, so this is positive, And this is what? Now, if I plug a positive number in for x, a positive number to any power is what? Positive, right?
Yeah.
And positive times positive is? So that's our answer. So then, as x approaches positive infinity, f of x approaches positive infinity.
So how would it be neither?
Yeah, that's right.
It can't be. It can
No?
never be neither.
Why would it give you the choice?
I put that just to pick out people that just to give the clueless another opportunity.
I put
None of you will do
3
that.
on 2 of them.
You did, now you won't though.
No, I won't.
Now you won't. See, I just wanted it's there as a what do they call it? They call it a distractor when you run the test. It's there to give you another. I want you to know, the more choices you have, the less chance if you're just guessing you're gonna get it right. But now you all know how to do that. It's been don't feel bad. It's been a long time since we
That's
did that.
easy now. I was making it a lot more.
I just didn't get it whatsoever, so I just.
Let's look at one more quick example of that. What if we had f of x equals, let's say,
-2.
x to the 7 plus 3x to the 4th minus 1. How about that? Okay? As x approaches negative infinity, f of x approaches what kind? Positive or negative? Okay, how you getting that?
Because you
Negative.
negative is equal to
Exponents
negative.
can't be negative, so
Okay, good. So if we look at this leading term, right, we're getting -3 times x to the 7.
I'm gonna say R goes up.
Okay, so this -3 is negative. What about x to the -7? Now, if I'm plugging in a negative value for x, a negative number to an odd power is negative. A negative number to an even power is positive, right? And that makes sense, doesn't it? Because if I have like -3 to the 8th, well, that's just the 4 pairs of 2, right? If I have an even number of negative numbers, there's always 2 that can go together and cancel, right? Does that make sense? So let's. I'm going to make it small. Say we have -2 to the 5th. That equals -2 times -2 times -2 times -2 times -2. Well, those 2 become positive. Those 2 become positive. I always have a single negative left over if it's an odd number, right?
Right.
That's why. If it's an even number, they'll always all become positive, won't they? Right? Okay, so then our result here. A negative number to an odd power is negative. Negative times negative equals what? Positive. See? Okay.
So if it was like, instead of x to the 7th, or whatever, negative x to the 7th, if it was like negative x to the 4th, it would be positive?
Right. If this had been an x to the 4th, then a negative number to an even power would have been positive. We would have had negative times positive gives us an overall negative sign. Exactly. Okay? Make sense? Okay. All right, so what's the leading coefficient?
10.
The number in front of the biggest power of x, 10. Right. What's the, we got a factor. Okay, let's do this one. Okay, so if we're asked to factor this, now we got 2 terms, right? So if it's 2 terms, we're just going to have to fit this to one of our factoring patterns. Which pattern fits? Okay, what about cubes? Sum of cubes?
No.
Difference of cubes. There we go. Okay. Okay, what is that pattern? We got to remember what that pattern is.
Something A.
A minus B.
minus, minus. No, always plus. The last one's always plus. So there it is. Okay. So all we've got to do then is we've got to figure out what's going to act as our A and what's going to act as our B for this case, and then follow that pattern. In other words, 27x cubed can be written as what quantity to the third power, and 8 can be written as what quantity cubed?
3 and 2.
Okay, so this one's going to be 3 is that when I distribute that power, 3 cubed is 27, and then I need an x in there too, don't I?
Yeah.
Okay, and then over here I just need a 2, right? So then 3x is acting like our A, 2 is our B, right? And so we're just going to follow this pattern. So A minus B is just going to be 3x minus 2. Now, if you're going to make a mistake, that's the one that you're going to miss. What is A squared? A squared. A is 3x. What's... No.
27.
9x squared,
Okay.
right? Because 3x squared is just 3x times itself. 3x times 3x is 3 times 3 is 9, x squared, right? So 9x squared, and from there on out it's easy. Plus 3x times 2, 6x. 2 squared is 4. Okay, now we always want to just look at that and make sure there's nothing that we can factor out of each of those, and there isn't, right? There's no greatest common factor. Okay, now here's the other question that you might have, and we talked about this, but I can see why you might not remember this vividly. When we're factoring something, we need to factor it completely. So the question remains, this is done. Is this done, or can it be broken apart more? It's done. It's always done. In this pattern right here, what we get for the quadratic part is always done. You don't go any further. Okay?
So is that whole thing your answer? Or just
So this whole thing is our answer then, that times that.
So the last part's just a remainder.
Well, this is right. This is, I mean, it's because sometimes there are certain polynomials that if we divided them out using a different pattern, right? If we were, I mean, sometimes we can take a quadratic expression and factor it further, but those will never factor further. So this one would be written as, how would we put it in Moodle? How would that be entered in the answer box in Moodle? Parentheses. Yeah. All right, that's a time sign.
Why did you don't have
You know, I would, just in case. Especially when it's between quantities, I think.
I never had.
Wait, that's multiplication.
Maybe you don't have to, but I think there are certain cases where you need to. I know on certain calculators, like TI-89, if you don't put that in there, sometimes it won't do it right, sometimes it will. So it's always a good idea between quantities, between sets of parentheses, I would always put a times sign on. Okay? And when you do this in college, you'll be using certain, like if you use, for example, Mathematica, I don't know if Mathematica or MathCAD, one of the computer algebra systems that you're likely to use in college tells you you have to do that or it could be wrong. So it's just not a bad habit to get into. Yeah.
Are you good at drawing?
Oh, not really.
You draw rabbits.
I draw rabbits. If there's time at the end of class, I'll try to draw a rabbit for you. How's that?
I'm very suckish at drawing.
Is the smartboard bulletproof?
He has a smartphone bulletproof.
Oh, one second.
Oh, for sure.
We try it?
No.
Smartboard can be bulletproof.
I was just wondering if you were good at drawing.
You bulletproof?
I am, absolutely. Okay, so what about this one? Factor this guy.
Group it.
Group it. There you go. Very good.
We went to college, that's where yeah, that's
Okay, now here we go. Grouping. Let's review grouping. Okay. When you do factoring by grouping, remember that you could, I mean, we know how the whole problem has to unfold. We could fill out all the little parentheses and write the template out for the whole problem and just fill in the specifics afterwards. In fact, I think it's not a bad idea to do that because it helps you keep straight what you're doing. So first of all, I know that I'm just going to write this as a sum of two groups. The first two terms are in the first group, second two terms are in the second group. Now, once I've done that, before I even write it down, I know that I'm going to factor a greatest common factor out of both, and I'm going to have a leftover factor from both, right? And that plus sign's still there. First group plus second group. And furthermore, I know that those must be the same, right?
Yeah.
We already know how the whole thing is going to play out here, if it works. So now let's fill in the blanks. First two terms, just 5x cubed plus 6x squared. And I, honestly, before we even do this, what I didn't do, but I should have done, is we should always ask ourselves, is there a greatest common factor from everything that I can pull out before I even start to factor it out? But there isn't this time, so. Okay, so what's the greatest common factor from the first one? X squared. So if I undistribute an x squared, what am I left with?
5x and 6.
Plus 6. Okay, so that has to go here, right? Then the only thing I have left to find out is what goes there and does it work for both terms? What times 5x is negative 20x? Negative 4 times 6 is negative 24. It checks out.
So does that mean x squared is negative 4? No. No, it doesn't. Not quite. Now we got one more part of this that we haven't done yet. The part that we haven't done yet is being as these two are the same, this guy and this guy, we can grab those from each term, factor it out, right? So we're left with, we've got a 5x plus 6. When I take those away, I'm left with x squared minus 4, right? Okay, that's a good answer, but it's not perfect. That's not the whole answer yet, because when we're asked to factor something, we're asked to factor it completely. Now this guy's done because it's got an x to the first power. Is this one done? No, it's not. That's a difference of squares, isn't it? We can think of that as being x squared minus 2 squared. And then it's going to follow that difference of squares pattern. So that one's going to break apart X minus 2 squared.
X minus 2 times x plus 2.
Mr. West, would you call extension 3804, please?
Because our difference of squares pattern just looks like this. A squared minus b squared equals, remember, it's a plus b times a minus b, either order, right?
You're gonna be able to have to print out all these formulas, right?
Sure, that's fine. So that's it. Now we're done. Right now, all those are to the first power as x's, so we're done. Okay. So there's grouping. Okay, what about this one? Find the least and greatest real solutions of the polynomial equation. Okay. Okay, talk to me about that one now. What kind of a polynomial? What's going to be our technique here? How many terms have we got?
The difference of x squared or the factor.
Okay, yeah, we got 3 terms. It's like a quadratic trinomial form, isn't it? Right. So what are our options here? This is chapter 5 kind of deal. We can either factor it if it works, or quadratic formula. Sure, right. So now, does it factor? Are there 2 magic numbers that multiply to positive 36 and add to negative 13?
No.
You sure?
Multiply to 36. Oh, yeah.
Okay, negative 9 and negative 4, right? So this does factor. We could break this apart.
Could you just do a quadratic formula then?
Yeah, but we could also, right.
So we could either do this. We could either set this up as x squared minus 9 times x squared minus 4 equals 0. And then those are pretty easy to solve. Now, being as we're just trying to find the zeros, we don't need to factor this further. What can we do with our factors to find the zeros? Okay, I could set them equal to 0 and solve. Now, I could factor further, but I wouldn't. That's a waste of time. We can just set these equal to 0 directly. I could say, when is x squared minus 9 equals 0? Well, when x squared equals 9, which is when x equals what? Or negative 3 plus or minus 3. So there are two answers, right? Now, what about over here? We could set that equal to 0, this factor, which is when x squared equals 4, which is when x equals plus or minus 2. Okay, so now the question asked us for the greatest and the least real zeros. What's our greatest real zero? 3. What's our least real zero? Negative 3. Yeah, right? Those are the two extreme answers right there. So our answers then would be least real solution, negative 3. Greatest real solution, positive 3. Okay? Now, we could have also, done this. Okay, we could have also recognized that this is quadratic and A is 1, B is negative 13, C is 36, and so we could use the quadratic formula. Negative B plus or minus square root B squared minus 4AC all divided by 2A. Now, what's equal to all that stuff? Is it x? X squared, right? Because this is like saying x squared squared minus 13x squared, right? This is like chapter 5, only instead of x's, we've substituted in x squareds, right? So we could have done that, and solving that would have given us the same stuff. If we did that, when the dust settled, we would get the answers either x squared, if we take the plus version, that's going to give us square root of 25 is 5, so 18 over 2 is 9. Or we take the minus, 13 minus 5 is 8, over 4 is, over 2 is 4. Right? That looks familiar. So now, you mean either we mean either that, or you mean either quadratic or factoring?
Either x squared equals 9, x squared.
Well, we have to do them both. Right? We wouldn't be done. We'd have to go down there and say if x squared equals 9, x equals plus or minus 3, or x equals plus or minus 2. There are my 4 zeros. The greatest real would be 3.
Okay,
Right.
I got you.
Okay. Okay. Let's see if we have time for one more. One more out of the way. Well, that's got to be later. Okay, what about this? Can we do this one? Oh, man.
I don't think so.
I think we should just start with that.
I'll just draw a rabbit.